The Battle of the Atlantic was not merely a contest of courage or industrial output. It was, at its core, a lethal geometry problem that the Allies were losing for the first 3 years of the war. In the freezing expanse of the North Atlantic, the German U-boat fleet, commanded by Admiral Karl Dönitz, had nearly strangled the United Kingdom into submission by exploiting a fundamental flaw in British anti-submarine technology. The sheer terror of the U-boat peril was the only thing that Winston Churchill admitted ever truly frightened him, and for good reason. By November 1942, German submarines were sinking Allied shipping at a rate that far outpaced the capacity to build new vessels, sending 119 ships to the bottom in a single month. The equation of survival was breaking down. The British Isles were starving, fuel reserves were evaporating, and the industrial machine needed to fight the war was being starved of raw materials. The Germans were winning because they understood the limitations of their enemy's eyes and ears better than the enemy did, exploiting a technological blind spot that turned every escort attack into a game of blind man's bluff, played with high explosives. The root of this catastrophe lay in the physics of ASDIC, the active sonar system used by the Royal Navy. ASDIC was a marvel for its time, capable of detecting a submerged object up to 2,000 yards away by bouncing sound waves off its hull. However, the system had a fatal weakness that German commanders utilized with ruthless efficiency. The sonar beam projected forward and downward from the escort ship at an angle of roughly 10 degrees. As the hunting ship closed in on the submarine to attack, there came a point usually about 300 yards from the target, where the outgoing ping and the returning echo merged, and then the target passed beneath the beam entirely. This created a cone-shaped blind zone or dead time directly in front of the ship. For the final, critical moments of an attack run, the British destroyers were essentially blind, deaf, and guessing. They had to estimate where the U-boat would be, based on its last known trajectory, steam over that position, and drop depth charges from the stern. German doctrine was built specifically to exploit this window of invulnerability. A U-boat commander, listening on his hydrophones, could hear the propeller revolutions of the approaching destroyer increase as it prepared to attack. He knew that once the pings of the ASDIC stopped, the escort had entered the blind zone. In that moment of silence, the submarine would execute a violent, evasive maneuver, turning hard to port or starboard, or changing depth rapidly. The British ship, committed to its course, would pass overhead and roll depth charges off the stern rails onto empty water, exploding where the submarine used to be, not where it was. To make matters worse, the massive concussions of the depth charges created millions of bubbles and turbulent water disturbances that rendered the ASDIC useless for 15 minutes or more. During this death period, the submarine could slip away in the acoustic chaos. The statistics were damning. 5,174 depth charge attacks resulted in only 85 confirmed kills, a dismal success rate of roughly 1.65%. The Royal Navy was expending staggering amounts of ordnance to churn up the ocean while the U escaped to kill again. The solution to this existential threat did not come from the established naval hierarchy, which was often paralyzed by tradition and bureaucracy, but from a Canadian chemist named Sir Charles Frederick Goodhue and his team of eclectic innovators at the Directorate of Miscellaneous Weapons Development, known affectionately and somewhat derisively as the Wheezers and Dodgers. This department was a collection of scientists, engineers, and sci-fi writers who operated outside the stiff rigidity of the Admiralty. One Goodhue looked at the problem and realized that the geometry of the attack had to change. If the ship had to pass over the submarine to drop charges, contact would always be lost. Therefore, the ship must not pass over the submarine. The weapon had to be thrown ahead of the ship, landing in the water while the ASDIC operator still held the target in his crosshairs too. It was a concept of elegant simplicity that required a complex engineering execution, a mortar system that could fire a circular pattern of bombs 200 to 250 yards ahead of the vessel, trapping the submarine in a cage of explosives. The resulting weapon, designated the Hedgehog, was a marvel of unconventional engineering. It consisted of a spigot mortar system, a design adapted from an infantry anti-tank weapon, which was lighter and produced less recoil than a traditional barrel mortar. 3. The launcher was a steel cradle bolted to the ship's foredeck, bristling with 24 solid steel rods or spigots. On each spigot sat a 65-pound projectile. The firing mechanism was electrical and staggered. Ripples of electrical impulses ignited the propellant charges in pairs, launching the bombs in a specific sequence to minimize the stress on the ship's deck. The rear rows fired first at a steep trajectory, and the front rows fired last at a flatter trajectory. Yet the ballistics were calculated so perfectly that all 24 projectiles slammed into the water simultaneously in a circle 130 feet in diameter. However, the true genius of the Hedgehog lay not just in how it was launched, but in how it detonated. Depth charges relied on a hydrostatic fuse, meaning they exploded at a preset depth regardless of whether they were near the target. For if the captain guessed the U-boat was at 100 feet and the boat was actually at 250 feet, the attack failed. The Hedgehog projectile, by contrast, used a contact fuse. 5. It would only detonate if it physically struck a solid object, This solved two massive tactical problems simultaneously. First, it removed the need to estimate the enemy's depth. The bomb would simply sink until it hit the submarine or the ocean bottom. Second, and perhaps most importantly, a miss was silent. If the projectile sank without hitting anything, there was no explosion to blind the sonar. The ASDIC operator maintained contact throughout the attack, allowing the ship to reload, which took about 3 minutes, and fire again immediately, correcting their aim based on the previous miss. The engineering required to make this contact fuse work was substantial. The mechanism had to be robust enough to survive the violent impact of hitting the water at high velocity without detonating prematurely, yet sensitive enough to trigger instantly upon striking the steel hull of a U-boat. The solution developed by Lieutenant Commander H.D. Lucas involved a striker held back by a spring and a soluble washer. When the bomb hit the water, the force pushed the striker back, but the washer prevented it from hitting the detonator. As the bomb sank, the seawater dissolved the washer, arming the weapon. If it hit the soft mud of the ocean floor, the impact wasn't sharp enough to overcome the remaining resistance. But if it struck steel, the striker drove home, detonating 35 pounds of Torpex, an explosive 50% more powerful than TN, directly against the submarine's pressure hull. Despite the theoretical brilliance of the Hedgehog, the Royal Navy's establishment fought its adoption with furious resistance. The Directorate of Torpedoes and Mining argued that forward-throwing mortars were guns, and therefore not their responsibility, while the Directorate of Naval Ordnance viewed the project with skepticism. It took a bypass of the entire chain of command to get the weapon into service. Goodhove, utilizing his connections, arranged a demonstration for Winston Churchill at the Prime Minister's country estate, Chequers, bluffing their way past security. The DMWD team set up a demonstration that initially failed to capture Churchill's interest, until his daughter, Mary, insisted they watch. The sight of 24 projectiles arcing through the sky and splashing into the water in a perfect lethal circle mesmerized Churchill. He immediately grasped the implications of the silent water entry and the lack of disturbance. With the Prime Minister's decisive backing, bureaucratic hurdles vanished, and the Hedgehog entered mass production. Yet, the introduction of the Hedgehog into combat in 1942 was not an immediate triumph. In fact, for the first few months, the weapon seemed to be a failure. This was largely a psychological issue rather than a mechanical one. Naval captains and crews were conditioned to the drama of depth charges. When a depth charge exploded, huge columns of water shot into the air, the ship shuddered, and the crew felt they were doing something violent and effective. With the Hedgehog, a miss resulted in silence. The bombs simply disappeared into the black water. To a stressed crew in the middle of a battle, this silence felt like impotence. They believed the weapon was a dud. Consequently, captains would often ignore the Hedgehog and revert to depth charges, even though the statistics proved depth charges were failing. It got so bad that the Admiralty had to issue orders requiring captains to provide written justification if they failed to use the Hedgehog on a contact. The turning point came through rigorous training and the dissemination of success stories. At HMS Ferret in Londonderry, the primary anti-submarine training school, instructors began to deprogram the crews, teaching them that silence was not failure. Silence was the opportunity for a second shot. They explained the lethal mathematics. A depth charge might damage a sub with a near miss, but a Hedgehog hit was almost always fatal. A single 35-pound charge exploding against the hull at deep submergence caused a catastrophic breach. The pressure of the ocean would rush in at hundreds of gallons per second. While the internal atmosphere of the submarine spiked in temperature and pressure, it was a brutal, instantaneous end. As crews began to trust the weapon and integrate it with better sonar, and the new creeping attack one ship held contact while another approached slowly and silently. Kill rates skyrocketed. By May 1943, the Battle of the Atlantic shifted permanently. This month, known as Black May to the German U-boat fleet, saw the destruction of 41 U-boats, nearly a quarter of their operational strength. 6. The convergence of centimetric radar, long-range air patrols, Enigma codebreaking, and the Hedgehog weapon overwhelmed the German defenses. The blind zone, the U-boat's primary sanctuary, had been erased. German crews began to refer to their vessels as iron coffins. The psychological impact of the Hedgehog on the enemy was profound precisely because it was so mysterious. Survivors from Hedgehog attacks were incredibly rare. U-boats simply vanished. German intelligence struggled to develop countermeasures because they didn't fully understand that the British were attacking from the front. Maintaining sonar contact the entire time, they tried acoustic decoys and rubber coatings, but nothing could stop a weapon that required only one solid acoustic fix to deliver 24 contact bombs. Lethal efficiency of the Hedgehog is best illustrated by the incredible combat record of the USS England, a Buckley-class destroyer escort commanded by Lieutenant Commander Walton Pendleton. 7. In a 12-day period in May 1944, the crew of the USS England displayed a mastery of the weapon that remains unmatched in naval history. 8. Operating in the Pacific, they intercepted a Japanese submarine scouting line. On May 19th, they sank I-16, On May 22nd, RO-106. On May 23rd, RO-104. On May 24th, RO-116. On May 26th, RO-108. Finally, on May 31st, RO-105. 6 submarines destroyed in under 2 weeks. In several of these engagements, the first salvo scored hits. The crew's ability to predict the submarine's movement and the reliability of the Hedgehog system turned the USS England into a singular force of destruction. Admiral Ernest King, upon hearing the news, famously declared, "There'll always be an England in the United States Navy." The statistical comparison between the old methods and the new was stark and undeniable. While depth charges struggled to achieve a kill rate of less than 2%, the Hedgehog eventually achieved a success rate of nearly 20%, 10 times more effective. In the hands of a skilled crew, it was a death sentence. The weapon required only 5.7 attacks to generate a kill, compared to the 60.5 attacks required for depth charges. 9. It was later supplemented and eventually replaced by the Squid, a massive 3-barreled mortar that fired larger, depth-fused projectiles which could be set automatically by the sonar computer. The Squid was even more effective, achieving a kill rate of roughly 33%. But it was the Hedgehog that first broke the stalemate. It was the Hedgehog that bridged the gap between the era of guesswork and the era of precision anti-submarine warfare. The legacy of the Hedgehog extended far beyond the capitulation of Germany in 1945. It set the standard for all future anti-submarine weapons. The Soviets were so impressed by the system that they reverse-engineered it to create the MBU-200 and later the MBU-6, evolving into the RBU-6000 rocket launchers that are still seen on Russian and Indian warships today. 10. The United States Navy kept Hedgehogs on their destroyer escorts well into the Cold War. The concept that a ship must attack while maintaining sensor contact became the foundational doctrine of modern naval warfare. The days of steaming blind and hoping for the best were over. Ultimately, the story of the Hedgehog is a testament to the power of lateral thinking in the face of desperate odds. When the traditional methods led to failure and the death of thousands of merchant seamen, it took a group of outsiders to look at the geometry of the battlefield and ask a simple question: why are we throwing explosives where the enemy was, instead of where he is? The answer saved Britain from starvation and played a decisive role in breaking the back of the Kriegsmarine. For the German submariner in 1943, the war changed from a hunt into a horror story. He no longer had a blind spot to hide in. He no longer had the safety of the deep. He would hear the ping of the sonar, and then, without the warning splash of a depth charge or the noise of a propeller overhead, his world would simply end in a flash of torpex and crushing water. The hunters had become the hunted, and the Atlantic was no longer theirs.